So now here I'm going to give another example. Okay. I want to solve the equation 9x squared plus 3x minus 20 equals 0. Okay. So here, I'm going to recall my previous example. Now this time, I'm not going to go through the whole rigmarole of like making all the possibilities. But what I'm going to do is I'm going to go straight to the heart of what we did last time to find out what these possibilities are. That is, I'm going to make a table for my leading coefficient, and I'm going to make a table for my constant term. By doing this, and I'm going to look at what the numbers get me close to, and I'm going to use that to figure out which possibilities are worth writing down, and I'm going to test those possibilities. Okay? Okay. So let's do that together here. So I know that to get a negative 20, okay, I can either multiply 1 times 20, where one of them is positive and negative. I can multiply 2 times 10. I can multiply 4 times 5. I can multiply, let me see, 5, 4, 5. I think that's all the factors, okay? And then here, I want to multiply to give me 9x squared. Now here, I could have 1 times 9, or I could have 3 times 3. And that's essentially it. But now, what I need to realize is that my middle term is going to be positive 3. Now, if I look at these, okay, let's start playing with the 1s and the 9s. If I were to look at 1 times 1 and 9 times 20, I'm going to get a huge number. 9 times 20 is like 180, right? So 180x and a 1, that's nowhere near 3. Say if I do 9 times 2, that would be like 18. 1 times 10, that'll be like a difference of about 8. And of course, if I do 9 times 10, that's 90. And then 1 times 2, that would be also not close to, anywhere near close to 3. And if I do 9 times 5, that's 45. 1 times 4. And on the other hand, 9 times 4 is 36. 1 times 5 is 5. 36 and 5 are hugely separated. Okay. But if I start looking over here with the 3s, by the way I'm multiplying these numbers, what I want you to think about is that I'm trying to see which numbers, when I multiply one of these with one of these, get me close to where the difference or sum is going to be 3. Because then I'll know which ones to explore. So let's say I do 3 times 20. That's 60. 3 times 3, that's 1. That's nowhere near each other. They won't have a difference of 3 by any means. 3 times 10 is 30. 3 times 2 is 6. 30 and 6, that's a difference of 24. Now here, 3 times 5 is 15. 3 times 4 is 12. Aha! Here, the difference between them is 3. So I know that I'm going to expand the 3 and the 3 and the 4 and the 5. So the possibilities there are as follows. I either have 3x plus 4 and 3x minus 5. Or, alternatively, I have 3x minus 4 and 3x plus 5. Okay. Now, if I look at the middle terms here, I'll get negative 15x plus 12x. That will be negative 3x in the middle. Here, if I have 3x times 5, that's 15x minus 12x. Aha, that's my plus 3x. This is my factorization. Now, let me highlight what I was doing there one more time. So our original example was this monstrosity where we had 12 possible factors, and we systematically wrote them down. We checked each one, and then we found the one that was good enough. We found the one that was not good enough. We found the one that worked. If you carry out this multiplication, you will recover this quadratic. But what I did in this second case is I made my tables for my constant term and for my leading coefficient, okay? But then, instead of writing down all the possibilities like this, what I did was I tried to simulate what the constant term, what numbers over here when I multiplied it, would give me close to the constant term. So for example, here in the original example, I did 2x times 12. That would be 24x, and then negative 1 times x is minus x. So 24x minus x, that's 23x. So the way I look at this in the table is like this. I say, okay, 2 times 24, and then 1 times 1. So I'm going to have 24 and 1. And if I add or subtract them, right? So here it was a subtraction. So because 2x, that's the 24, minus 1. So I can see that if I were to do that here, that's not going to get me anywhere near to the negative 5, right? And if I did 1 times 12 and 2 times 1, that would be 12 and 2. The difference there would be like 10, nowhere near negative 5. So then if I look over here, right, what I'm doing is I'm multiplying the 2 times, either I'm going to multiply the 2 times the 6 or the 2 times the 2 and the 1 times the other one, right? So 2 times 6 is 12, 1 times 2 is 4. 1 times 2 is 2. So 12 and 2 will be like positive or negative 10, depending on the way the signs are. And that's also not near the negative 5. So in other words, what I was doing here is what I was doing over here. So instead of writing out all these possibilities, what I'm saying is I'm going to see which numbers give me products that get close to having this term, and then I'm going to expand those out, and then I'm going to figure out if one of them is a factor. Now, of course, if that's not successful, I can always just list out my whole table of possibilities and just explicitly either find it or maybe find out that the polynomial is not factorable, right? And of course, we're going to learn techniques for solving those non-factorable cases later. Yes.